Hello, and welcome to the second lesson for this unit. It is about bond types. And what is a bond in chemistry? A bond holds two or more atoms together. And here I've listed three types of bonds. We have the ionic bond right here with where one or more electrons are transferred to form oppositely charged ions. So we have a picture showing this. It's where the electrons are not shared equally. The sodium actually donates one of its electrons over to chlorine, who happily takes it, and then we end up with a +1 charge on the sodium atom and a -1 charge on the chlorine atom, and that forms an ionic bond. A covalent bond, on the other hand, is where two atoms share the electrons equally. Here we have two chlorine atoms, and they're very similar in their characteristics, and they share their electrons equally. And then in the case where it's in between, not really completely ionic and not completely covalent, we have what we call a polar covalent bond. It has some components of each of those types of bonds. So how do we know which bonds are actually being formed? Are they ionic? Are they covalent? Well, in order to answer that question, we are going to look again at the idea of electronegativity, which is the ability of an atom to attract electrons to itself. And if you'll remember from last week, as we travel left to right on the periodic table, we increase the electronegativity of the elements. And also as we travel up the periodic table, we increase electronegativity so that fluorine is the most electronegative element on the periodic table. And this is important because, if you'll recall, I said last week, these numbers that are listed here, 4.0 for fluorine, for example, it's not a number that's important in and of itself, but compared to the other atoms, it's very important. So we're going to see that in bonding, we're very concerned with the difference in electronegativity values. Here is just a little kind of a line showing over here on one end covalent character, and over here ionic character. As the difference between the two atoms, electronegativities, increases, their character becomes more ionic. As a matter of fact, a difference of 2.0 in electronegativity between the two atoms gives us an ionic bond, if it's 2.0 or greater. A difference of 0.0 gives us a covalent character. So two atoms, to be truly and purely covalent, need to have identical electronegativity values. In between, we have all of our polar covalent bonds with different characteristics. Sometimes the polar covalent bonds tend to be a little more ionic character. Sometimes they tend to be a little more covalent character. But those are the rules for determining whether a bond is ionic or covalent. Now, if you would just take a moment, you can pause the video and try some of these problems on your own. I've given you 3 sample problems that you can try and find out, and then when you turn your device back on, I'll give you the answers. Okay, I'm sure you got all of these correct. The first question, order these elements from most electronegative to least. Simply based on periodic trends, you should be able to figure out that the order is sulfur, iron, titanium, and cesium. Then what type of bond would be formed in each of the following molecules? We have 2 oxygens bonded together. They are the same, and the difference in electronegativity is 0, so they form covalent bonds. Here we have an ionic bond with potassium fluoride. Their difference in electronegativities is greater than 2. And magnesium chloride, the difference between magnesium and chlorine electronegativity is less than 2, but it is greater than 0, so it's a polar covalent bond. And the last question, which molecule's bond has more ionic character? Well, the difference between potassium and oxygen in electronegativity is greater than the difference between potassium and nitrogen. So you could actually determine this even if you didn't have a list of electronegativity values. Simply by looking at periodic trends, you would know that this is the molecule that has more ionic character. So what can I do for a 4? If you would like to achieve advanced proficiency for this particular lesson, you can research bond polarity and dipole moments. So those were not included, but you can use your textbook as a resource and any of the other options on the screen here. And these are the objectives for that, and that will certainly earn you a 4. So we'll see you in class.